Okay, here we are on the third question of section 1a. Find two distinct square roots of I. Well, okay, this is very interesting. Like, I is the square root of 1, and now we're being asked to find the square root of 1. It's almost, I don't know what's happening. So, arbitrarily, let's just call the square root of I x. So x is going to be, it's going to be two values, right? Which means that x squared must equal I. Okay? Let's just assume that x is a complex number because I don't know any real numbers when squared equal I, right? So we're going to assume it's a complex number. Okay, and once we've done that, we can, okay, so the complex number, that's a complex number, right? We expand it, the x is a complex number, expand it, becomes a squared plus 2abi minus b squared. And we could do the same trick as we did in the first question, where we separate the variables into a 0 here and a 1 here, because I is 0 plus 1i. And then we've got the real terms, which are here and here. You know what? I'll change colors. The I, I'll make it green. The 1i. And you've got that, 2ab as the coefficient of I. Okay, and then same trick. Same trick as the first question. You can split it up, and now you've got two equations and two unknowns. You can solve for those unknowns. Yeah, so I started on the left-hand side here. Started on the left-hand side and went b equals 1 over 2a. And then that's 1. Dragged 1 over to the left-hand side, substituted in for b, and so b squared, move it over to the left-hand side, you get positive b squared, so positive 1 over 2a squared, which is 1 over 4a squared, and you can multiply across the a, you get 1 over 4, a to the power of 4 is, don't forget the plus or minus, because you're taking the fourth root of something. So I took the fourth root of both sides. Don't forget the plus or minus, because when you've got an even root, it can be either a negative or positive version of that square root that when squared gives you the value under the root sign, right? Okay, so kept going. Fourth root of 4 is the same as the square root of 4, so I took the square root of 4, which is 2, so the square root of 2. And multiply top and bottom to rationalize the denominator, and we got root 2 on 2. And now we can make that, put that into our 2, and then bring 2 over to the right hand side, substitute in b, and then so substitute for a right there. And yeah, I think that's pretty easy. Get plus or minus root 2 on 2. Whoa, they're the same. Now it's asking for two distinct square roots of I, and I don't know about you, but I see plus or minus for both my answers. You can either do plus minus. We have, so we've got plus minus plus and minus. We've got 4 combinations of these, and I don't know which 2 are going to give me the distinct values of I. So I tested all of them, and these aren't that hard to test because, as you can see, those cancel out, and then root 2 on 2 is 2 on 4, which is 1/2. 2 1/2 is 1, so that must be I. And then negatives, negative times a negative is positive, negative squared, so that is exactly the same as that, so that must also be correct. And I could have stopped there and said, oh, I've got 2 distinct square roots now, those are my answers, but I didn't, because I just was curious, I wanted to know. does it work when you do the plus minus combination? And it doesn't, because that, well, that's exactly the same. Now you haven't got one fraction, and that's actually negative I, because you've got root 2 times root 2 is 2 on 4, negative 2 on 4 is negative 1/2 times 2 is negative I. Same thing would happen here. So you get negative I instead of I. Interesting. So our solutions are root 2 on 2, root 2 on 2, or negative root 2 on 2, and negative root 2 on 2. And there you go. That is the answer to question 3 of 1A. I'll see you in the next one. I might call it a night tonight or do one more. We'll see. Have fun. Good luck.